The following content has been provided by RWTH Aachen University.
Now, Jeff talks about 3 human deadlines in his book that I think are very much very helpful to reason about different kinds of responsiveness. The first one is exactly what you just said, the 10th of a second, the one that we know from Bloch's law. The delay that you start to notice between cause and effect once you move beyond the 100 millisecond mark. So for example, if I click a mouse button, the button on my mouse, and I click on a button on the screen, I expect that button to turn black or whatever, or to invert its color, or to press itself in visually within 100 milliseconds. If it happens slower than that, it will feel sluggish. The delay between the mouse moving and the pointer following is at least limited by 100 milliseconds. I would even say it's more. Recently, people have studied things like touch screen latency and how it affects users. And we're probably looking at even lower latencies here for continuous movements. But that's something that hasn't quite worked out yet. But it is certainly 100 milliseconds or less. The second delay that, or the second latency deadline that Jeff postulates is around 1 second. Now, don't take this as like exactly 1,000 milliseconds. It's an order, right? It's an order of magnitude, and this is a typical delay that you get in situations like this. So, for example, I might say, "So, how was your evening last night?"
Good.
Okay, very good. So he answered within 1 second. Do you notice that? Widely awake, obviously, that's good. But also, when we have a normal conversation, when you have a normal conversation with another person, and you finish your sentence, you expect some kind of reaction within a second. If they just look at you blankly for a second, then you're like, that's weird, right? So what we do then, we also react to this. So what we do is we either answer right away, like good, or we put in something like, or we like start nodding or make eye contact, show that yes, I'm processing, I'm thinking about the answer to your question. So if somebody doesn't answer for longer than 1 second, it seems weird. And that's the typical turn-taking sort of latency in conversations. It's also the minimum in reaction time for unexpected events. If all of a sudden you're driving down the Autobahn and all of a sudden something happens in front of you, you need around a second to even process this and react. So if things take longer than that, then and you look at the computer as a conversational partner in a way, then things start to be weird. So here's an example. Let's say I click that button with my mouse, and it inverted it within 100 milliseconds. That's the physical response that I need, so that it feels like a realistic physical button, right? That's what we're simulating. Now we have a little more time. We've inverted the button within 100 milliseconds. Now we have about 1 second of time where if the button is there to, for example, open a window, and we can do opening the window within 1 second, we don't need to show a progress bar for that. It's not necessary. That would be very weird and actually probably too much action on the screen. But if the button is there to load a file, then if we can load the file within 1 second, great. If we find that we need longer than 1 second to load the file, we need to do something. We need to, for example, put up a progress bar. Right? So after a maximum of 1 second, you expect, as a user, you expect some kind of semantic response, if you like, some kind of real response, not just I inverted the button because I clicked it. Clicking the button, inverting it is something I expect to happen as a physical response almost. And then the next level, sort of the conversation that's going on, where I want to see, did the computer understand it? Is it working on the task that I gave it? That's where you have 1 second, and if that 1 second is over, then either you're done or you have to start showing a progress bar. Finishing something that the system initiates also is a similar example. Let's say you have autosave in your application. Sometimes you find you type something, and for a moment the system becomes sort of sluggish because it's autosaving a file. If that's within 1 second, okay, right? If it takes any longer, it should definitely display something and show that it's processing. Finally, the third delay is 10 seconds. This is the typical human attention span. I know that's sad, but that's what it is. So if, let's say you are looking at that progress bar, right? Because the file loading takes a little longer. And you see it moving along, and it takes about 5 seconds. You'll probably sit there and just basically waste 5 seconds of your precious life looking at that progress bar. Right? We don't start anything else in those 5 seconds. If it looks like it's going to take 30 seconds, your attention is going to wander, right? You're going to probably go like, oh, let me see if I have a Facebook status update or whatever, or you're going to do something else. So what that means is, after 10 seconds, we have to expect the user to have put their attention somewhere else. And now we need to get it back once we're ready to continue our interaction with the user. Plus, we need to be aware that he may be out of context a little. Right? He's done something else and is now coming back. So ideally, you manage to let people complete whatever they are trying to do. Remember the closed exits, closed dialogues, and visible exits rule. You enable them to complete the task they're trying to do, like entering a check into a banking program or completing one step of a multi-step wizard within these 10 seconds, so that they stay with it and feel like they can complete it in a comfortable amount of time. Or if somebody selects the print menu, then the dialog pops up and he wants to print something, he should be able within 10 seconds to fill this in under normal circumstances and hit print, so that it doesn't take much longer.
This content was provided by RWTH Aachen University.